Hello and welcome to another edition of the Science Chef educational series on chemistry. In this video, you will learn how aluminum is extracted from its ore through a combination of the Bayer and Hall-Héroult processes. At the end of this lesson, you should be able to state the major ore used in the extraction of aluminum, describe how the ore is purified, describe the electrolysis of alumina, state the functions of cryolite in the extraction of aluminum, and finally, you should be able to write the equations of reactions that occur during the process. Make sure you go nowhere, as we'll be right back after this break. But before that, can you write down some facts that you know about aluminum? Welcome back. Before the break, we asked you to write down some facts that you know about aluminum, and I hope you are done with that. Alright, let's do this. Aluminum is the 13th element in the periodic table and the third most abundant in the Earth's crust after oxygen and silicon. Due to its lightness, high resistance to corrosion, and non-toxicity, it is used for making aluminum foils and cans used in foods and drinks packaging. It is also used for making overhead cables and pots due to its high electrical and thermal conductivities. The major source of aluminum is bauxite. Other sources include kaolin, mica, conundrum, and cryolite. The extraction of aluminum starts with the purification of bauxite, otherwise known as the Bayer process. Bauxite contains alumina, also called aluminum oxide, with iron 3 oxide and some triazosilicates as impurities. It is the iron 3 oxide that gives the bauxite its reddish brown color. The impurities are removed by dissolving the bauxite under pressure in concentrated sodium hydroxide solution in the presence of heat. The alumina, being amphoteric, dissolves in the caustic soda solution, leaving behind the basic impurities, mostly made up of iron 3 oxide, as seen in the equation. The mixture is filtered to obtain a solution of sodium aluminate 3 as the filtrate. Few crystals of pure aluminum hydroxide are added to the filtrate to precipitate aluminum hydroxide according to the equation on the screen. The aluminum hydroxide is filtered, washed, and dried to obtain pure aluminum hydroxide crystals. The pure crystals are then heated strongly to obtain pure alumina as shown in the equation of reaction. The next stage is the electrolysis of alumina, called the Hall-Héroult process. The Hall-Héroult cell is made up of steel lined with carbon cathode, and big blocks of carbon hang in the middle of the tank and act as the anode. The electrolyte is a mixture of molten alumina and cryolite. The cryolite is added to reduce the melting point of alumina to about 950 degrees Celsius and make the process economically viable. It also acts as a solvent and increases the conductivity of the alumina. Before the electrodes are connected to the power supply, the ions in the molten alumina move randomly after dissociation. On connecting the electrodes, there is a migration of ions based on the electrostatic law of attraction. The oxide anions migrate to the positively charged anode, while the aluminum cations migrate to the negatively charged cathode. At the anode, the oxide ions undergo oxidation by losing 2 electrons to form oxygen gas as shown in the anodic half equation. The electrons lost travel through the external circuit to the cathode. At the cathode, the aluminum ions undergo reduction by gaining the electrons to become deposited as metallic aluminum according to the cathodic half equation. In order to balance the number of moles of electrons transferred in the electrolytic process, we would multiply the oxidation half equation by 3 and the reduction half equation by 4, and then combine the 2 balanced half equations to get the overall cell reaction. After a while, the molten aluminum is tapped off and poured into molds and allowed to cool. Meanwhile, the oxygen gas liberated at the anode reacts with the carbon graphite to form carbon 4 oxide, and after a period of time, the anode wears off and has to be replaced regularly. This is a major challenge in the extraction process. It is expensive and adds to the overall cost of the process. That is all you need to know about the extraction of aluminum based on your syllabus. Thank you for watching.